All right, a little help on number 69. Here we have the cloth hanging off. Part of it is hanging off and part of it is still on. And we need to figure out the ratio of the off part to the total mass. The mass of the off part to the total mass. So even though this is just one object, we need to separate it into two separate ones. So if you look at the on part, there are two forces that make a difference. The force of friction on the on part, because there's friction and they actually give you the coefficient of friction. So there's friction between the surface of the table and the cloth. On the other hand, this hanging part is tagging on it, so it's trying to move it, so therefore there's this, we can say it's force of pull of the off part. The off part, on the other hand, every action has an equal and opposite reaction, so the off part is tagging back on, the on part, I'm sorry, the on part is tagging back on the off part with this force, and there's also force of gravity on the, well, whatever that mass is, times g. And then I even made them the same color, so you would see that these two basically, again, it's every action has equal and opposite reaction, so these two forces are equal, which makes these two forces, the force of friction on the on part and the force of gravity on the off part, equal as well. These two are also applied to the on part, but they don't make much of a difference for us. So friction on the on part equals gravity on the off part. So moving on from there, we're playing with this equation. Physics is basically over. Right now it's just pure algebra. So force of friction on the on part. All I'm doing is basically using the formula for friction. Friction is mu times normal force. So then I can rewrite that instead of force of friction on, I'm writing mu times normal force on the on part equals force of gravity is mg, and that's the m of the off part. And from there, what I do is the on part, since it's flat on the table, the force normal equals the force of gravity on the on part. So we just replaced normal with mg, where m is the mass of the on part. Okay, so here didn't change much, didn't change anything. Anyway, the question of the problem here is mass of the off part. That is how they wrote it, but if you think, that's basically the mass of the whole cloth. So what I'm going to do is I'm going to replace this sum with just m, which is mass of the whole cloth, and then I need to get rid of m on, so I'm going to replace it with, that's basically total mass minus m off. So again, these two added together give you the mass of the whole thing. So then m on from there is just total mass minus mass that is hanging off. Let me get back. What I'm going to do after this, I'm going to work with this equation right here. So this is 0.4, they gave it to you. This m on I'm going to replace with that, and then that will remain whatever it is. G, we can basically divide by G and get rid of it. So it will be mu times mass on equals m off. Right? So mu is 0.4. That is our mass on, because it's total minus mass that is hanging off, over the total mass. And on the right, there was mu m off times G, and we just divided everything by total mass, which did not change much, right? Because we take the equation and divide it by the same number, both parts. Nothing changes. So then, Russian math for you. I'm opening, basically redistributing, and then that part right here, 0.4 times m over m gives me just 0.4. On the other hand, negative 0.4 times mass off over m. That's what that turns into. So again, that gives me 0.4. This times mass off with a negative in front over m, that's my second part. And then that's just the right part of the equation. Here, m off over m off over m This is basically multiplied by 1. That is multiplied by 0.4. So what I'm doing is I'm dragging this part with a minus on this side of the equation, and that gives me 1.4. So 0.4 equals 1.4 times mass off over m. That's basically what they're asking us for. M off over total mass. So then I divide 0.4 by 1.4. That gives me the question mark of this whole problem, which is m off over the sum of both masses, so the mass of the whole cloth. 0.4 over 1.4 gives you 0.29, and that is it.